Hello and welcome to the fourth, is it fourth or fifth?
Sir, fifth.
Fifth class on haloalkanes. In haloalkanes, we had studied the general methods of preparation of haloalkanes or alkyl halides. And also, we have studied the properties, particularly the chemical properties, the most significant properties of alkyl halides are A, substitution, and that too SN, nucleophilic substitution, because carbon bonded to halogen, that carbon has electrophilic character with a plus delta charge, and that is the electrophilic center for nucleophiles to attack. And the leaving group X minus, accepting fluoride ion, which is the worst leaving group, as it is a stronger base, being the conjugate of a weak acid HF. Only weaker bases are good leaving groups, like chloride, bromide, iodide, and iodide is the best, being the conjugate of the strongest of the strong acids. I mean, among the three hydrohalic acids. So therefore, Ri is greater than Rbr, greater than RCl. RF is never ever used as substrate for SN reaction. Now, we have studied elimination reactions also, how alkyl halides undergo elimination with alcoholic KOH. There we had a little ambiguity in our discussion, bringing the CBSE book, NCERT book, saying that aqueous KOH will bring about substitution, while alcoholic KOH will bring about substitution. That is not an acceptable thing in reality. But yes, for your CBSE board examination or CHSE board examination, because CHSE books are completely following the NCERT book, so I will not misdirect you to do something which is not there in the NCERT book. So if you are using ethyl chloride, ethyl bromide, ethyl iodide, and using alcoholic KOH, you expect ethylene, CH2, double bond CH2. You are using aqueous KOH, you expect ethyl alcohol. This is incorrect. Since ethyl chloride or ethyl bromide is a 1 degree halide, 1 degree halide gives a major product as substitution SN2, irrespective of the medium. You know, the breaking of the CX bond is common to both elimination and substitution. Whether it is SN1, SN2 or E1, E2, we have to have the Cl minus, Br minus, I minus has to go. They have to go. In a single step or multiple steps, it doesn't matter. So, since 1 degree carbocation is extremely unstable and is never ever formed, so in ethyl bromide, there is no room for any rearrangement. It will give you the same 1 degree carbocation. So, and OH minus ion, being a strong base, is a good nucleophile. Of course, it is a strong base. Well, if you heat, then it can undertake beta elimination to produce ethylene. Aqueous alcohol, this war, this fighting is actually misleading. The organic reactions are really carried out in organic medium, particularly ethyl alcohol and water. If you are interested in SN1, the solvent should be as much polar as possible. Since the substrates are not soluble in water alone, because it carries a hydrophobic part, all organic compounds, you have to add as much ethyl alcohol as it is required. So a mixture of ethyl alcohol and water is used for all the carbocation activity. But if you are sure that you are using a weakly polar solvent like acetone, a protic solvent like acetone, then you are interested in SN2, where polarity has to be reduced so that the nucleophiles will not be jailed inside the poles, the positive poles of the polar solvent, and they are immobilized. The nucleophilic attack becomes slowed down. So we use acetone as the SN2 solvent. So let's start today. Welcome, Miss Shruti and Shreya. You have been missing for the last decade. I feel like आजकल तो अरे temperature is 27 but feels like 30, 32. In the same way, you were actually missing a few classes, maybe a couple of classes or 3 classes, but it feels like as if you are absent for 1 decade. Doesn't matter. I know you were otherwise busy. And welcome, Miss Prachi. I met your grandpa. I spent a long time with your grandpa day before yesterday. Um, he has been constantly inviting me to go to your house. Yes, I say always yes. I always give a precondition. I will definitely see Prachi. No, yes, yes, yes. You will definitely see Prachi. Okay. So we had completed SN1, all detailed analysis SN2. Today we shall be taking off SNI. This is internal. That happens not for alkyl halides. Since we are studying the SN mechanisms in details, therefore we will be having other substrates other than alkyl halides. When we take alcohol, we know PCl3, PCl5. These two, they undertake the substitution by inversion, SN2. But if you take SOCl2, thionyl chloride, you get RCl, it is only for chloride, SO2 plus HCl. But if there is a chiral center, supposing here is CH3, this is CH2, CH3, this is H, and this is OH. You are giving SOCl2. So remember, if there is no solvent like pyridine, look to the solvent. If there is no pyridine, then it will be retention of configuration. The Cl will be there on the same side. This is retention of configuration. And what is the configuration here? 1, 2, 3. This is S will remain S. S-butan 2-ol will remain S2-chlorobutane, because the priority of OH, O and Cl in these two molecules remain the same, the top ranking group. That's why say the retention of configuration is the key. But remember, if you find same thing, you give in SOCl2 with pyridine, then there is inversion of configuration. The Cl will come here, Me will go here, Et, H. So this S will be converted to R. That is inversion of configuration. Now it goes via the mechanism is intramolecular, the cyclic transition state. It passes through an intramolecular cyclic transition state. I am showing you to save time. I am showing you. We are missing Samidha, who might be oversleeping. Okay, to save time, I am showing, and I will urge upon you to write in your copies. Now see what happens. I am making it little bigger. Are you able to see what happens?
Yes, sir.
Now see, without pyridine, what happens? The O, the O lone pair goes for a nucleophilic attack to thionyl chloride, expelling chloride ion in two steps. This is nucleophilic acyl substitution, which is different from SN, but nucleophilic. We will talk about the details of acyl substitution in our carboxylic acid program. Now it has two steps. First, the pi bond will polarize, and then it will come back again. Cl minus will go. Otherwise, then deprotonation happens to produce an intermediate, a stable intermediate, which you can isolate. This is called alkyl chlorosulfide. But if you leave it for some time, there will be a intimate ion pair. This heterolytic cleavage of the carbon oxygen bond will take place, but the ions will not be separated. There will be intimate ion pair will be there. There is no room for any carbocation activity, because the O minus will not leave that carbocation to do any nuisance. And immediately the chloride ion from the second chlorine will come as chloride ion, attack as a nucleophile from the same side, and this lone pair will come here. This Cl minus will attack on the same side. So there is a retention of configuration with expulsion of SO2. I think you understand all. Are you?
Yes, sir. So,
But if
so
you
ଯଦି so ଯଦି ପ୍ରାଇମେରୀ ଥାନ୍ତା ବି ହେଇପାରିଥାନ୍ତା?
अरे बाबू प्राइमरी थिले भी हब, but there is no point in talking about inversion or retention. How can you measure experimentally that retention is happening? Yes, it must be happening, because it has been proved beyond doubt with chiral centers. You have to take no, look, you are using this one only to create a chiral center. If you take 2 degree, oh sorry, 1 degree, same thing will happen, but retention of configuration will carry little meaning. Little means no meaning, understand?
Yes, sir. Yes, sir.
That is why I selected a chiral center. Yes, it will happen. But in presence of pyridine, two things will happen. First, pyridine will be a player. First step is the formation of chlorosulfide, alkyl chlorosulfide. This intermediate, I have not repeated. I have just copied the alkyl chlorosulfide intermediate, then pyridine. Before the intimate ion pair is formed, it will not be formed in this case. Pyridine will be playing as a kebab in haddi, as a haddi in kebab. It will attack as a nucleophile, and there will be acyl substitution, chloride ion. This chloride ion will be left out free, and एडे गोटे गोटे बुढ़ा ता पछरे हेलानी ओ एस डबल बॉन्ड ओ pyridinium मिसिकी गोटे बुढ़ाटा हेलानी so this won't go. Instead chloride ion जेहेतु फ्री हे गला then सीए आसीबो पछपटू अटैक करिवो छत्ता उल्टीबो and as a result you get inversion of configuration. You understood?
Yes, sir.
But with PCl5, PCl3, the mechanism is SN2. I have shown here that with PCl5, one chloride will go, deprotonation will make it neutral. That chloride ion will attack from the other side inside the umbrella, and then the umbrella will invert. So there is inversion of configuration. Okay, then I think I would like to show you without wasting time, and I will urge upon you to write down the corresponding allylic rearrangement, SN reaction with rearrangement. That is also called conjugate SN reaction that you will encounter in IIT Advanced. Supposing you are given a double bond and chlorine in the allylic position, and you are using NaOH AC or alcoholic, doesn't matter. So this is a primary allyl but primary CS2 sp3 hybrid carbon is there. Now I will explain to you the difference between kinetically controlled mechanism driven reaction and thermodynamically driven reaction here. Now what happens? Why a carbocation is formed? You see the mechanism, because allyl carbocation is stable, not very highly stable like 3-degree carbocation, but allyl carbocation is stable due to resonance, due to conjugation. So it will be formed, and then this will come, there will be allylic rearrangement. Now see, there are two resonance structures for this, and this one is a secondary allyl carbocation. This is a primary allyl, this is a secondary allyl, which is more stable. So this will be kinetically driven. Now the thermodynamically more stable product will be the minor product. The major product will be the rearranged product, where the, because of the stability of the intermediate 2-degree carbocation, allylic and 2-degree, the activation energy will be lowered down and the kinetics will prevail to produce major product as this. But from the original carbocation, what is the thermodynamically stable product will be the minor product. I have shown you with percentage data in one example. In this example, I did not have the data with me, but still I had suggested this will be the major product, which is kinetically driven product will be the major product. So it is a kinetically controlled mechanism, and the thermodynamically stable product will be the minor product, because the double bond is an internal position which is more stable thermodynamically, but thermodynamics is being hijacked by kinetics. They always remain at war, kinetics and thermodynamics. Not always, sometimes. Now, in this mechanism where the sp2 carbon is substituted here, you see, where we get a 3-degree allyl in the mechanism, we get a 3-degree allyl in the mechanism. I have selected only a simple 1-degree allyl, which will be converted to 2-degree. But if there is another substitution, it will be a 3-degree allyl. So the percentage you see, the kinetically controlled product is 85% as against 15%. I'm sorry. there's a mistake here. 15% of the normal product, as we write normal product, that is SN1 product, and this is SN1 dash. When there is a rearrangement, is 1 dash. Conjugate SN, it is SN1, it is SN1 dash. Now, see, this is an example. You are taking a labeled carbon, a labeled carbon 14. This carbon is carbon 14, deliberately taken to confirm the mechanism. You are using ethyl alcohol. That is a solvolysis process. Obviously, it has to be, as such, it has to be SN1, but now it will be SN1 dash. But since the nucleophilicity of ethyl alcohol is very low, is being a weak base, now you get 50-50. Now what will happen that there is no substitution here, so that is primary allyl and this is also primary allyl. In the previous cases, there was one methyl in this case here, and there are two methyl in this case. So clear cut, there is an edge of kinetically controlled product over thermodynamically controlled. But here thermodynamics and kinetics will shake hands and will give 50-50 in this case. And this will be SN1 dash, cannot be SN2 because it is weak base. You can think of SN2 and SN2 dash in this case. But since allyl carbocation is stable, so there is a carbocation and there is a rearrangement. We are getting a rearranged product also. Therefore, it has to be SN1. But in SN2, you will see SN2 dash also is possible. Rearrangement in single step is also possible. See, SN2 dash, if you take a strong nucleophile, if you take a strong base, OH minus, still the mechanism is in the favor of SN1 dash. But if you are taking SH minus, last time we talked about a softer base, down the group like SH minus, RS minus, PH3, all these are weak bases, weak nucleophiles, but, weak bases, but strong nucleophiles, I'm sorry. Weak bases, but strong nucleophiles. Now, supposing you take SH minus instead of OH minus, let me show you little now here also we have seen labeling of the carbon that we made. It was only to show the mechanism has really happened. The rearrangement has really happened because there is no substitution here in the sp2 carbon. So this is also ethyl allyl ether. This is also ethyl allyl ether. But if you level it, you get 50% of the ether, where the alkoxy group is attached to the normal carbon, and in another 50% you will find ethoxy group is bonded to the leveled carbon. Here also we have labeled this carbon, which is connected to the leaving group, but it is having another alkyl group. So since this has a greater nucleophilic power, although a weak base, it is a weak base, but a strong nucleophile being a softer base. So it will attack in one step and this will go, and there will be one chiral product and one achiral product. You see, if this is the rearranged product, which is achiral, but if SH minus comes here without affecting the double bond, keeping the vinyl group intact, SH minus attacks, then it will be the chiral product. This is a chiral center, not only labeled, but it is a chiral center. This star mark or the dot mark is not for chiral center, I think. it is due to the labeling. No, chiral center. I'm sorry. This is not labeled chiral center. So you get both the products, and that has to be SN2. SN2. So the attack, simultaneous attack in a rearrangement mode and direct mode has happened. You just read out. I'm saving time. Even now, if there are two chlorine atoms, it has been found experimentally because of the minus I effect of chlorine, the carbocation is highly unstable. In that case, even a strong base and a strong nucleophile like ethoxide ion will not like to produce a carbocation and follow the SN1 dash track. Instead, it will follow the SN2 dash. So whenever there is dash product, there is always non-dash product also. So here you get a non-dash product and a normal SN2 product. And here you also get the major product here, this one. Why this is minor, this is major? Because there is no carbocation formation, but this is a more substituted alkene, an internal alkene. Here the thermodynamics takes the lead to make this as the major product. So the details I have written, you can study. SN1 dash is more possibility in most cases than SN2. I mean SN2 dash, SN1 dash is more common, SN2 dash is less common. Only when there is a strong nucleophile but weak base in that case, and if there will be minus I group attached to the leaving group, the two leaving groups are there. One of them will really go, the other one will remain to create problems, minus I effect. In that case, you get SN2 dash. So by mistake, I have written chiral here. So I have, since it is already done with other, software, other feature. So I have written here, read a chiral for chiral. Is not a chiral molecule as chlorine, chlorine and are same. But had it been bromine, iodine, then iodine would have come. The livability of I minus is more than. So always you get a question if there are two I and Br, ICl, and 1 mole of this, the reagent is taken, then which will go? I minus will definitely go as against Cl minus. So you'll be doing a lot of organic things as you enter into aromatics in every case. In after this, we will be taking haloarenes, chlorobenzene in a big way. Now, similarly, SN I dash is also possible. Using thionyl chloride, and if there is an allylic, OH, although it is not halide, it is alcohol, but allyl alcohol with a substitution here. So, had there been no allyl, then there will be retention of configuration here. This is a chiral center. But since it is an allyl, so carbocation will be formed here. No, there is no carbocation formation in I, but you see the rearranged product will be there. See how rearranged product will be there. The non-rearranged product, you know how the OSOCl will be produced. The alkyl chlorosulfide stable product will be, intermediate will be formed, and which will rearrange with an intimate ion pair mechanism to retain the configuration. But here you see this is SN dash product. Well, there is no chiral center left out. This is a chiral, but you are also getting the rearranged product. Now see how rearranged product is obtained. Once the chlorosulfide is produced in this position, then the cyclic mechanism, this chloride ion will come here, this will go rearrange, and this will go. So you also get the rearranged product. But obviously the SN dash product is more thermodynamically stable. That will be the major product. Okay, I will give you the task of writing because we will go to elimination today. Therefore, I discussed this homework is to write down SN1 dash. Whenever there is 1 dash, there is SN1 product will be also there. The question is which one is more, which one is major, which one is minor. In many reactions, it is kinetically driven. Before thermodynamics shows its head, which is a very elephant-like motion, kinetics takes the lead, takes the equilibrium in favor of the kinetically controlled product with a lower activation energy, more stable carbocation. So SNI dash, SN2 dash, SNI dash. And also homework is SNI mechanisms, both without, with and without pyridine. The mechanisms are slightly different so that the chloride ion is set free in presence of pyridine and comes in the revert in the opposite side and brings about SN. And not SNI, but it is inversion of configuration. SNI, but inversion of configuration. But the I term is a little meaningless here. SNI internal always pertains to retention. But here inversion is happening in the name of SNI, SN2 is happening. But alkyl chlorosulfide is formed, which is a common feature of, which is the important feature of SNI is the formation of alkyl chlorosulfide intermediate. All these things you must write in your copies. Then elimination, beta elimination, as we say, beta elimination will be looking to so many eliminations. E2, I can write down like this, like this also. It लिखले भल लगे E1, E1 CB, then SIN, then Huffman or anti-Surgev, then ये पांचटा आगे देखिवा तापर हम देखिवा अन्य कौन अछि पांचटा. Let's write down E2 is bimolecular, is is having a lot of common feature with SN2. As you know, I have already told you the stereoelectronic requirement for here E2 3 degree is greater than 2 degree, greater than 1 degree halides. Contrary to what many people think, then 3 degree the carbocation is more stable and therefore the mechanism will be E1. No, absolutely not. Elimination, let me be very candid. When elimination is the major product in alkyl halides, the predominant mechanism is E2. So we already learned that in 3 degree halides with strong base, the major product is elimination. And sometimes it is 100%. With the 3 degree halides with alcoholic solution of a strong base, OH minus, CN minus, OR minus, alkanide ion, amide ion, Grignard reagent R minus, the mm, the absolute exclusive product will be 100% elimination, and that too E2. I've categorically written, when elimination is the major product, the alkyl in alkyl halides, the predominant mechanism is E2. And I will write another sentence, powerful sentence, in E1 later. 3-degree, 2-degree halides with strong base like OH minus, OR minus, NS2 minus, CN minus, alkynide ion, carbanion, etc. They will definitely give elimination as the major product. And that too, the mechanism will be predominantly 3 degrees, predominantly E2. 100% E2 as against the general belief. I will tell you a story. I will share my experience with you later. Not that a scientist who has established the mechanism has done so out of guesswork. He has done with a lot of corroboration that the intermediate, if it is E1, intermediate is being formed. Carbocation is being formed, and once the carbocation is formed, there are methods how to trap it. There are many carbocation trappers. Just like you throw the net and catch fish. Similarly, carbocation trappers, the reagents are there. So they will immediately throw that to the reaction mixture and not allow the carbocation to continue further. And they analyze the product formed, the new product formed, to prove that carbocation is being formed in the course of reaction. There was absolutely no evidence for the formation of carbocation in 3-degree halides. Despite 3-degree carbocation is being the most stable carbocation, I mean, among many. Tatu adhika asati, you know. The aromatic carbocations like tropylium ion, like other aromatic, they are more stable than 3-degree, no doubt about it. But 3-degree has a very high position in the stability, as we have already studied. Now here in E2, what happens, there will be only one step via a transition step. This is the beta hydrogen. That is why it is called beta elimination. You are using a strong base. I'm not writing V minus. Strong base will have a negative charge. All. See. Then that will abstract a beta position. This is the alpha position with respect to halogen. This is beta. That is why it is called beta. Alpha elimination is also there. We are not discussing that. That will be discussed when we study mechanism involving carbons, where chloroform and similar compounds will be subjected to alcoholic KOH. Then elimination will occur at the same carbon to produce an intermediate carbon, and then carbon will be undertaking further reaction, whether insertion reaction or other cheletropic cycloaddition reaction. There are so many reactions of the carbons that we will come across during our journey. But here, the strong base will abstract a beta proton, and this pi bond will break down, and this will go. So I'm showing reversible sign, and there will be a transition state, not intermediate. This bond will break. This, there will be B minus delta, and there will be some partial bond will be formed with hydrogen, and this pi bond will partially break, and this bond will also partially break with X as minus delta. So what will happen? Minus delta will be -1, because there will be conservation of charge. So it will be minus delta. So this is the TS, transition state, not any intermediate. And then ultimately this will go without statically, and double bond will be there plus BH, because it will be a covalent compound. B minus and H plus, they will combine to produce. Supposing it is OH minus and H plus, will give you the undissociated water. Supposing it is Cn minus and H plus, it will be HCN. That will be gas. It will go out. BH plus X minus. X minus will find its partner, because X minus, this these are all having their partners Na plus K plus. So that will be joining with X minus. So you get, and the most important stereoelectronic requirement is anti-periplanarity. I think I have sounded this word, right? The two living groups, there are two living groups. One on the alpha carbon, the other one, alpha carbon is the halide ion, and the beta carbon, the H plus, which will be abstracted by a strong base. The two living groups lie anti with respect to each other. In the TS. In the TS, then only the bond breaking, bond remaking, formation of double bond, and the removal of X minus will be smooth. There will be no, torsional strain. I mean, bond opposition strain, that will not be there, and the transition state will involve minimum activation energy, and it will be faster. So the stereoelectronic requirement for E2 elimination is anti-periplanarity. I will show with law. And before that, let me tell you the rate law. K into the substrate concentration followed by the base concentration, strong base concentration. That is why it is E2. Although it is a single step process like SN2, E2 is also a single step process. It's a single step process. That is why it is E2. And I'm showing you, supposing you are using I'm deliberately taking other compounds to show you the mechanism. Who can tell me, is it meso or it's an active compound? This is 2,3-dibromobutane. Is it meso or active? Who's running?
Meso.
Is meso, because there is a point of symmetry, inversion center. If you rotate by 180 degree, you can visualize a plane of symmetry. But eclipse conformation is not a reality. We tell to general students, I mean an average student, that there is a plane of symmetry, but that can be visualized in eclipse conformation, which is a non-entity. That never, any molecule doesn't remain in eclipse conformation for any detectable time period. It is a passing phase. When the rotations are happening very fast, they have to go via the eclipse conformation. But at a given point of time, you will find all the staggered formats. The three staggered formats you will find, where the bromine will be anti, bromine will be Gauss, there will be mirror images. So this is the most stable conformation, where the steric, strain is minimum. Bromine, bromine are anti, methyl, methyl are anti, and this is meso, right? So when you carry out debromination minus Br2, can you tell me what reagent you take to carry out debromination, dehalogenation of vicinal dihalide that we studied during the preparation of alkenes? Anyone? दिटा को ब्रोमीन जीवा पई हमें कौन नौ रिएजेंट?
सर जिंक।
Yes, zinc ethanol. Ethanol is the solvent and distill it so that it will form. This is E2 mechanism. And you get a trans. Interestingly, you from meso, you really get a trans or the E product. Which proves beyond any doubt that the stereoelectronic requirement in the transition state is anti-periplanarity. These two living groups, this will go as Br plus, this will go as Br minus, and both of them will combine with zinc to produce ZnCl2. ZnBr2, I'm sorry. But if you take an active compound, just making a switch at any one carbon and also bring the same stereoelectronic factor, so I'm just changing CH3H and here making CH3H so that this is active form. We can't say immediately whether it is RR or SS, but one of the active forms. Forget about its configuration at the both chiral centers. So this, I have put it in the anti-periplanarity mode and E2 mechanism, zinc, alcohol, heat, then this same thing will happen. Are you getting cis or trans?
The cis.
Methyl, methyl will remain on the same side. Hydrogen, hydrogen will remain on the same side. So you get Z or cis butene. So unless you know what is the stereo, and I'm giving you another example where you can, I'm showing you directly, giving you the transition state directly. So this is not a symmetrical compound. So question of meso doesn't arise. It will be either erythro or trio. Because there are four optically active, 2 to the power 2, 4. One is RRSS, the two enantiomeric pair. The other one is RSSR, which were meso, one and the same in the symmetrical compound, like the one we discussed before. But here RS and SR, they are enantiomers. And one of these enantiomers they're related as diastereomers. As you know, this is a repetition. And if you know, uh, alcoholic KOH, we are trying to dehydrohalogenate HBr. One living group is H plus, will be removed by OH minus, and Br minus will go. Can you tell me whether it is erythro or trio? And then I have told you how to convert it to the Fisher formula mode and also assign the configuration, whether it is RRSS category or RSSR category. But first you have to tell me when one group is dissimilar, other two groups are identical. In that case, they are related to trios and erythros of uh, carbohydrate chemistry. So we borrow the term erythro and trio, not erythros, erythro and trio, to give a general configuration of the two pairs of enantiomers. When the non-identical groups are aligned or eclipsed, you find the identical pairs are also eclipsed. So that is erythro. Just like in erythros, you will study carbohydrate chemistry in our program. Oh, just give me a bit. Just 2 minutes. Guys, I'll be taking 2 minutes for an important work, but I will hear. You be here with me, but I will pause. What to do? Pause, record. Welcome back, guys. So, this will produce, who can tell me it is E or Z?
Z.
Z. This is the Z product. And if you take the other diastereomer by making one switch, so can you tell me whether it is erythro or trio? You make a 180-degree rotation to bring hydrogen and bromine aligned in eclipse position, and you will find ethyl ethyl opposite, methyl methyl opposite. So that is trio. So this pair is a trio isomer. It may be, I don't know, unless we see its, I told you, first you have to make it a Y mode. I told you how you can, without any error, you can write the configuration. This is already in the Y mode. You bring it to the Y mode. ET will come here. This is ET. This is ME. તમે કરસાલણી રુદ્રાણી এটা
Yes, sir.
કોણ આર કન્ફિગરેશન કોણ બાହାરલા તમારો હા Y ମୋଡ୍ କୁ ଆଣିଲେ ଦେନ୍ ତାକୁ ଫିସର ଫର୍ମୁଲା ରଖିଲେ H ET ME BR ME ET. So let us look to this carbon. Bromine number 1, number 2 is between this bulky group and ethyl, which is senior. Bulky group or ethyl?
Bulky group.
Because this carbon is bonded to 2 carbon, but this carbon is bonded to only 1 carbon. So the bulky group is number 2. So number 1 bromine, number 2, then number 3. So this is moving in a clockwise manner, but this is opposite
S.
rule. Is opposite rule because the least priority group occupies a horizontal position. So this is S. Then we can't say whether the other one will be S or R. We can't say unless we do it because there is no mesoform here. Had it been a mesoform, then if it is S, this has to be R. Similarly, we have to give the configuration for the other one. In other, which one is number 1? Bulky.
Bulky.
The bulky carbon is bonded to bromine. So this is number 1 and number 2, number 3. And we have to use the normal rule 1 to 2 to 3. Hydrogen occupies the vertical position. So what is that?
R.
R. So this is R. This is R. This is S. And according to nomenclature, as you say, you bromine 1, 2, 1, 2, 3. This is 1, 2, 3. So 1, 2, 3, 1, 2, 3. So you have to give alphabetical priority. So 1, 2, 3, 4, 5, 6. So this is 3 bromo, 3, 4 dimethyl, and this is hexane. So the 3s, 4r, this configuration. The moment you change one configuration, it will be converted to its diastereomer. Supposing I change here between ET and ME, keeping every other thing fixed, so that I am this configuration becomes X. This was already S. So this is a diastereomer. I am not showing the enantiomer RS, SR, they are enantiomers. I have selected only three. This becomes erythro. This is erythro because when you bring bromine and hydrogen on the same side, ethyl, ethyl, and methyl, methyl will also be coming together in the same side. I mean, eclipsed. So that is erythro. So one of the erythro pairs that I have selected, that under the same condition will produce the E. This is the E3,4 dimethyl hex 3-ene. That is Z. So this is what we call stereospecific reactions. A particular stereoisomeric reactant will give you a particular stereoisomeric product. That is called a stereospecific reaction. 100%. If one stereoisomeric pure reactant will give you a mixture of two stereoisomeric products, then it is stereoselective, which we will be doing a lot of examples where we had done regioselective, regiospecific, and we will be also doing stereospecific and stereoselective. But many authors, they use the term stereoselective in a very casual manner. For every purpose, they use stereoselective. They say might be 99.9%. They say highly stereoselective to stereospecific reactions, but I always prefer if it is more than 95%, then let us be candid by addressing it as stereospecific, and if it is less than 95 or 9, we call it stereoselective. Are you following me what I am saying? Aryan?
Yes, sir.
Aryan?
Yes, sir.
Good. So, we'll be spending little more time today. ଯୋଉମାନଙ୍କର କିଛି ଅନ୍ୟ କିଛି କୋଚିଂ ଫୋଚିଂ ଅଛି, I give you the full authority to leave the class and watch without fail the remaining part that you have missed out. So this is all about E2. Then coming to E1, let me tell you the in alkyl halides, E1 occurs when elimination is the minor product. Of course, same. This trend is same. I mean, the order is same. But remember, when you are using a solvolysis reaction, weak base, then the substitution is the major product. Maybe today we are not able to distinguish and make a tabular form. When elimination will be measured and what mechanism, and when substitution will be measured, what mechanism will be discussing substrate wise, 3 degree, 2 degree, 3 degree, 1 degree, and 2 degree, which has a mixed mechanism, all elimination, but which one will be the major one? That will be making a summary maybe in the next class. Rudrani might be feeling very, very sorry that the number of classes have been reduced because sir has started class 11 program. Look, you are chand dino ka mehman. Another 3 to maximum 3 months we will be finishing our program. Then you will be asking me your doubts. I will be sitting on the advanced doubts only. During doubts clarification, many things which by mistake or by chance I had not told you by that time, that will be also told. That is the advantage of the doubts clear sessions. Sometimes I miss out some word, just like a Huffman word term I was missing in preparation of amines from alkyl halides. ammonolysis of alkyl halides is called Hofmann ammonolysis. The term sometimes in many texts it is missing out. So I missed out telling that word, but I found in last council examination, last council examination, uh, the question setter categorically asked Hofmann, what is Hofmann ammonolysis or preparation of amines? Then many wrote the Hofmann bromamide reaction, which I have not yet discussed, is same as Hofmann ammonolysis. No, that is amide converting to amine. It's not ammonolysis reaction. When ammonia is used, this is ammonolysis of esters, ammonolysis of acid anhydrides, and also ammonolysis of acid chlorides. When ammonia is used, but Hofmann ammonolysis is selectively used for alkyl halides. I told you in the last class. Now see, when you are using weak base, solvolysis reaction, elimination is the minor product. Supposing you are taking third butyl bromide or third butyl chloride, and you are adding water. Simply you are throwing water or alcohol. If it is alcohol, then it is alcoholysis, that formation of ether. It is water, then alcohol. But that has to go via the carbocation mechanism. And the major product will be SN1. Let me be very candid here. 80% more than 80% will be alcohol, and supposing I don't check out the actual data, say 80% I write, and the remaining 20%, let me write 85%. Remaining will be the elimination. Sorry, 15%. This takes place by E1 mechanism. This is SN1 mechanism. So when there is no room for, there is no nucleophilicity, is a weak base, it cannot abstract so very efficiently the beta protons. Even if the probability factor is 9, 3,339, had it been a strong base, the probability factor would have, hijacked the mechanism in favor of E2. But here is a weak base. It cannot abstract so easily. Instead, being a polar solvent, it will be favoring the heterolytic cleavage. And once the carbocation is formed, water is taken in large excess. It is a pseudo first order reaction, and water will just attach itself to form the protonated alcohol first, and then deprotonation will produce the neutral alcohol. But some elimination, some abstracting power is still there. So elimination and substitution go hand in hand. So once the carbocation is formed, it will now, I will tell you the E1 mechanism, how it happens, just like 2 steps. First, you have to take a 3 degree, no doubt. First, the red determining step is the removal of the X minus, you get a carbocation. And if there is a chiral center here, different groups, then you will have a racemization. But here the question of racemization doesn't arise, because we are looking for the minor product and how it goes in E1 mechanism. The next step is the BH, the water, for example, the weak base, has to abstract a beta proton, a badhya. But ସେତେବେଳକୁ 85% ସରିଯିବନି kinetically driven substitution product. But ଏଇଟା जो ପ୍ରଡକ୍ଟଟା ହେଉଛି, ଡବଲ ବଣ୍ଡଟା ଏଠି ଲେଖିଲି, and CH3 ଟାକୁ ଝୁଲେଇ ଦେଲି ତଳେ କି ଉପରେ, ଏଇଟା जो 20% ହେଉଛି minor product, and that is E1. This is fast, this is slow, so it's a pseudo, of course this is elimination. So rate law is governed by the substrate concentration alone. Because this step is fast, the nucleophile water is taken in large excess. The order with respect to water is 0. That is why it is a first order process E1. And the second interesting factor, accepting ethanol, I'm going out of alkyl halide. মদ্য ছড়া other alcohols eliminate by E1 mechanism. Often by carbocation rearrangement. Rearrangement ର ଚିହ୍ନ ହେଉଛି ଏମିତିଆ shortcut ଚିହ୍ନ. Often by carbocation rearrangement. କିନ୍ତୁ ଆମେ ଯଦି ମଦ ନବା ଦୁଇଟା କାର୍ବନ ଅଛି ଏଲିମିନେସନ ହବ. ମିଥାଇଲ ଆଲକୋହଲରେ ଏଲିମିନେସନ ହବାର ନାହିଁ. କମ୍ ସଲଫ୍ୟୁରିକ ଏସିଡରେ ହିଟ୍ କରିବା ଡିହାଇଡ୍ରେସନ. ଏଇଠି ଡିହାଇଡ୍ରେସନ ଲେଖିଦେଉଛି ଅଫ୍ ଆଲକୋହଲ୍ସ. ସେଥିରେ ମେକାନିଜମ ଇଜ E1. एक्सेप्टिंग इथानॉल रे बाटो नहीं. सो एठी प्रथमे प्रोटोनेशन हैला, अदरवाइज लिवेबिलिटी विल बी नॉट देयर. H plus will protonate and enhance the livability because water will leave, that is a weak base and a good living group. Then जो रही जीवो H plus गला परे जो HSO4 minus रही जीवो, that will abstract a beta proton in a anti-periplanar E2 mechanism mode. So that bato kichhi nahi, and carbocation is unstable. Carbocation 1 degree carbocation unstable, rearrangement hobar nahi. So you get ATH2SO4 back to pavilion near water. So that is E2. Otherwise, there will be rearrangement. Even N-propyl alcohol will dehydrate by, although the product is only one propene, there is no second propene, prop-1-ene is the only one, but hydride shift will make it 2 degree isopropyl carbocation, but ultimate beta elimination, beta proton elimination will give you the same alkene. But talk about this E2, others E1. You can give me one yourself one. Supposing I'll give you this one. I have told you several times, Kong sulfuric acid hit. Even if this is 1 degree, alcohols, they don't bother about 1 degree, 2 degree, 3 degree. It is only 3 degree in alkyl halides under weak base solvolysis condition, give elimination as the minor product, and that only by E1 mechanism. I showed you this step. But here you are dehydrating an alcohol, and I told you that accepting ethyl alcohol, other alcohols dehydrate by E1 mechanism via carbocation. Any mechanism which goes via carbocation is a first order process, because the formation of carbocation is the slow and rate determining step. Now, who can answer me what will be the product? Common average students will say there will be no reaction because they don't find any beta proton. That beta carbon is totally substituted, no hydrogen. So no reaction. But what happens? Aryan wanted to tell something? Master Aryan.
No.
No.
Ki koibo?
तुम कह
हाँ.
तो 2-methyl but 2-ene.
Precisely. Because here will be rearrangement. I am showing you the steps. This step is not slow. So protonation will occur. I'm not writing in details. So HSO4 minus will go. It will be protonated, so the livability will be high. Since 1 degree carbocation is never formed, teachers, they say to make the average students understand. So this is now protonated. And then in one step, there will be rearrangement. This methyl shift will occur and this will go as water. Carbocation rearrangement, had it been there is a hydrogen at Thilebi, hydride shift ethanta. That is the migratory aptitude of hydride ion is more than alkyl ion. So there is no hydrogen. So tinta jako saman. ଯଦି ତିନିଟା ଯାକ ଅସମାନ ହେଇଥାନ୍ତା, then the migratory aptitude, which I will tell you while I will discuss alcohol about the migratory aptitude, more is the bulk 3 degree, it is the would thanta third butyl, it methyl, it isopropyl. Then there will be a lot of products, and the major product will be the bulkiest third butyl group migration. So the migratory aptitudes are not same. But here I've taken all the methyl groups. So one of them shifts as a carbanion. So you are left with a more stable 3 degree carbocation, and here methyl. And then since you are heating, then beta elimination thermodynamically, product, a stable product will be formed. Simply H plus ion will go, and you will get. All these are fast steps, excepting the formation of the carbocation. Here I should have given, this. I'm writing here methyl shift, the rearrangement of carbocation. There is no carbocation formation, so rearrangement word is little misleading. 1 degree carbocation is never formed. In one step, there is a methyl shift and formation of the most stable carbocation 3 degree, and then heating will undertake with proton elimination as such. Kichi base darkar nahi, or else you can HSO4 minus base ଅଛି, C8 will abstract, and then it will become H2SO4. So you get this major product. As always, as I told you, that it will be regio selective. The other product will be, this is major, and the other product will be the other one, this side. You get all possible products in elimination of elimination is not a regio wise, it is not a regio specific, it is regio selective. But stereo wise, it is a stereo specific only when you have E2. In E1, in alcohols, there will be so many rearranged products, multiple products. So regio word will be more appropriate than stereo word. No. Yeah. CS2, CS3. So this is minor, less thermodynamically less stable. This is more stable. So that is the thing which we have done several times. I told you that supposing you take this and give it, Kong sulfuric acid heat, or simply add HCl, no heat. So what? Sometimes Kong sulfuric acid is not written in the examination. H3O plus heat. This is simply HCl. Or simply HCl. If I make it H2O, H3O plus without heat, then there will be definitely rearrangement, and you get a ring expansion product with cyclobutane. Has a lot of angle strain, is very unstable, so it always wants to stabilize by expanding the ring from 4 to 5. So what will happen here, this will go after protonation. ମୁଁ ଲେଖି ଦେଉଛି କାଳେ ବୁଝିପାରିବନି କ'ଣ ମୁଁ ଦେଇଥିଲି ଅରିଜିନାଲ ଗଲା ପରେ, କିନ୍ତୁ ଏଠି ଯେହେତୁ 1 degree carbocation ହୁଏନି, so ଏଠି shift କରିଗଲା. So that I told you earlier also, ନମ୍ବରିଂ କରିଦେବ. ଧର ଏଇଠୁ ଯେକୌଣସି ଜାଗାରୁ ଷ୍ଟାର୍ଟ କରିବ, 1 2 3 4 5. So 1 ଏଠି ଥିଲା, ଏଠି ଲାଗିଛି ମାନେ 1 2 3 4 5. ଯେହେତୁ ଏଇ ବଣ୍ଡଟା कार्बन नंबर 2 रू इट हैज लॉस्ट कॉन्टैक्ट, तेणु 2 रे पॉजिटिव चार्ज आसीगला. देन इफ इट इज ए क्वेश्चन ऑफ हीटिंग, देन इटा तो सिमेट्रिकल जिनस जोटू गले भी सही हबो. सो H प्लस आयन विल गो, HSO4 माइनस तो अच्छी, किसी नथिले H3O प्लस लिखिदे, किसी लिखिया दरकार नहीं. କିଛି ଲେଖିବା ଦରକାର ନାହିଁ ଏ H2O ଖାଲି ବି ହବ H2O ମଧ୍ୟ ହବ HSO4 ମାଇନସ୍ ବି ହବ ହେଲା ହେଲେ ସୋ ଦ୍ୟାଟ୍ ତମେ ଯେହେତୁ ଦେଇଛି କ୍ୱେଶ୍ଚିନ୍ରେ H3O ପ୍ଲସ୍ ସେଇ H3O ପ୍ଲସ୍କୁ ବ୍ୟାକ୍ କରିଯିବ ଆଉ କ'ଣ ଅଛି ଦେନ୍ ୟୁ ଗେଟ୍ ସାଇକ୍ଲୋପେଣ୍ଟିନ୍ and if it is a substitution reaction the same with Cl minus will be Cl minus will be joining here I'm showing you in a different pane because I'm using the same intermediate so you get cyclopentyl chloride or chlorocyclopentane a ring expansion has happened whether it is elimination or substitution. I think we close today's session here at this moment. I thank all of you, Aryan, Prachi, Rudrani, and Shruti Shreya, who have their unflinching, attention, undeviated attention from the beginning to the end, which loudly speaks about their interest, their commitment, and their power of assimilation. See you in the next class. এটা ইম্পর্টাଣ୍ଟ ଜିନିଷ ମୁଁ ଏମିତି କେମିଷ୍ଟ୍ରିଟା ପଢ଼େଇଦେବି ଫଟକିନି ଏଇଟା ସାଙ୍ଗରେ ଏଇଟା ରିଆକ୍ଟ କଲେ ଏଇଟା ହବ କିନ୍ତୁ ଯେଉଁ ଗୂଢ଼ ତଥ୍ୟ ଗୁଡ଼ାକ ତମେ ନ ଜାଣିଲେ ସମ୍ ଅଫ୍ ୟୁ ଆର୍ IIT advanced minded and I always say when you are IIT advanced minded why not in a good position within 500 in the all India rank and because I can guide to that extent because of my experience. I have nurtured this experience right from the time when I was guiding my son when I was in Ravensa University. At that time it was not university and who got a good position as I told you 500 some odd position he had in the first time studying in Ravensa college at that time and and with passing time I had added to my experience more and more what I was teaching then and teaching now there will be a sea change in the in the content that I am disseminating because the teacher as I told you several times is more a student than a real teacher. A student reads less, prepares more for the exam, looks to the questions, but a teacher always studies. Every day he has to study more and more. Bye bye.
प्रणाम सर।